let's look at some inequalities here. We're going to replace this question mark with the symbol less than or greater than. Now we have two numbers, -3 and -4. Our job is to decide which one is larger. So what might help when you're approaching these problems, especially when you have negatives involved and you may not have a good feel for the size of the negative numbers, we might want to write or draw yourself a little number line. When we do here, we have -1, -2, -3, -4 will do it for us here. And then 1, 2, 3, 4 to the right. Now in fact, while we're at it, we might as well just go ahead and extend this just a little bit more this way and get -5, 6, 7, and 8. Okay, so there we have a regular number line. Here's 0. The numbers to the right are always positive. The numbers to the left are negative. Now, let's examine this. We've got -3, question mark, -4. Which one's bigger? Well, let's take a look at our number line. Here I find -4, and right next to it I find my -3. So which number is bigger? Well, we know from our work with number lines, the number to the right is always larger. So since -3 is to the right of -4 on the number line, -3 is larger than -4, or we can replace this question mark with a greater than sign. -3 greater than -4. Let's try another one. In the second problem, we're going to compare the two numbers, -1 and +2. This is probably a little easier for you because one's negative and one's positive. Here's -1 down here on the left, and here's +2 on the right. Again, the number to the right is the larger number. So in this case, since -1 is written first, -1 is smaller than 2, or we say -1 is less than +2. Finally, on the end, again, we're comparing some negative numbers. We have -8. Let's erase this. We don't need anymore. We have -8, and we have -5. We can clearly see by the relationship on the number line, the number further to the right is -5. So -5 is larger than -8. But since it's written in this fashion, -8 blank -5, we can say that -8 is smaller than -5, or we say that -8 is less than -5. So we'll replace this question mark with the less than symbol. Now that we have a feel for these inequalities, let's graph some inequalities. Let's graph the following inequalities here. Let's look at our first one. We're going to graph x is greater than 5. Okay, we're going to graph this on the number line, and we're going to state the relationship in words as well. So let's go ahead and draw a number line. Now in this particular case, we can put a few numbers, 1, 2, 3, 4. We don't have to mark them all. 5, -1, -2, just to get a feel of how the number line is going. Now let's first of all, we're going to do the two things. We're going to graph it and state it in words. Let's state it in words first. This is saying x is greater than 5. So we just write that out. X is greater than 5. That's simple enough. Now how do we graph a statement like that? X is greater than 5. Well, first of all, on the number line, we have to locate the number 5. Here it is, 5. Now, since it says x is greater than 5, it means it's not exactly equal to 5. It's just anything larger than 5. For instance, 5.1, 5.01, 5.001, anything directly to the right of 5 is what we're looking for. We're looking for all those values x that are just a little bit larger than 5 or a lot larger than 5. Now, which of the numbers on our number line satisfy that condition? Well, we leave an open circle because we do not include 5, But what that tells us is that we want to start from 5 and we want to include all the numbers to the right of 5 on the number line. Those are the numbers x, so all these numbers to the right of 5 are all our numbers x such that x is greater than 5. So that's the graph of the statement x is greater than 5. Let's try another one. Let's look at x is less than or equal to -2. Now since I just said that, you should have a good feeling for what that is. -1, -2, and we'll put some positive numbers on the right hand side. Now again, to read this inequality, we look at it and say x is less than or equal to -2. So let's write that out. X is less than or equal to, in this case we have -2. -2. Okay, again, x is less than or equal to -2. Now how do we represent this statement or this inequality on our graph? First of all, we locate -2 on our number line. Here it is. The difference between the first problem and this one is our second one says that we are less than or equal to that value 2. So to show the difference between strictly greater than or less than and less than or equal to, we're going to color in this circle because that means that the -2 is included in this inequality. Now we want all the numbers that are less than -2. Remember, less than are numbers to the left here. So that looks like this. Arrow to the left. So here's the graph of this inequality. X is less than or equal to -2. Up here, this is strictly x greater than 5. Let's try one last inequality. I guess we don't need any of this. One last inequality that's going to be stated in just a little different fashion. And let's see if we can figure out how to interpret it. This time we're going to write 3 greater than x. Sometimes when students see the inequality written in this fashion, it's a bit confusing. And I don't blame them because to me it's a bit confusing too. So what I like to do when I see the variable on the right hand side of the inequality, I personally like to have the variable on the left hand side because for me it's just easier to read or interpret. So what I'm going to do when I see this problem, 3 is greater than x, I'm going to rewrite this as x. Now we're looking at it from this side, reading from x. If we start from the right hand side and read towards the left, this looks like a less than sign, and that's exactly what it is. X is less than 3 is the same as 3 bigger than x. Just think about that. 3 bigger than x is equivalent to x less than 3. If you don't quite get it, you might want to take a second and pause, think about it, throw in some numbers and make sure they work. Make sure you understand this. I know it's a bit confusing for some people. So again, we're going to do the same thing here. Draw ourselves a little number line. And the first thing we're going to do, as we did in those previous problems, is we're going to go ahead and write this out in words. And as we just said, 3 is greater than x, or as I prefer to look at it, x is less than 3. Less than 3. So there we have it. Now that we have the inequality written in words, can we go ahead and represent it on our graph? Sure we can. Again, we're going to locate the number 3 on our number line. We have to decide, do we want to color in that circle or leave it open? The sign is strictly less than. So we're saying we want the numbers less than 3 but not equal to 3. So because we don't want those numbers equal to 3, we're going to leave that as an open circle. We want the numbers less than 3, so those are all the numbers to the left of 3. So we represent that by showing the graph to the left of 3. Inequalities might take a little bit of work. You need to practice reading them, especially when they're given in this fashion. Again, as I said, you could probably choose some numbers, substitute it in, and check to see which values work. Now let's see how we can use inequalities to represent some words. In this first paragraph it says, during the drying cycle, the temperature inside the clothes dryer must never exceed 180 degrees Fahrenheit. Let's let T represent the temperature of the clothes. It must never exceed 180 degrees, which means it must be less than, but it can also be equal to, because exceeding means on the other side of 180 or greater than. So less than or equal to 180 degrees will keep our clothes temperature not exceeding 180 degrees. Let's look at our second one here. It says the bank officer said that the total consumer debt incurred by Wally and Sally must be less than $15,000 if they want to qualify for a mortgage to buy their first home. In this problem, we're going to use D to represent their debt. So D here. And in this case, it says they must be less than $15,000. So we don't want to be equal to it, but strictly less than $15,000 to qualify for that mortgage. So we'll write this inequality as D is less than $15,000. This inequality represents what's going on in that particular word problem.